So I have my new network of all of my possible paths that could be built. And so now I'm going to see if I can use this to answer any of the questions. So it says, the Tapau Club would like the cycle network to provide the shortest route between Hamilton and Tapau. So we're going to have to do a shortest route. And there's several different ways we can do that, and I'll go through each of them now. There's several different ways. You can do inspection, which is when you basically hope that your network is so simple that you can just spot it. So that's kind of just spotting it and looking at it. Then we have the tree method, which we use to label all of the distances. And then we can have shortest arc from activated node. Okay. So the first one I'm going to do is I'm going to look at the shortest arc from the activated node. So let's label that so the person marking your internal can see what you're actually trying to achieve. So shortest arc from activated node. Now, what that really means is, if we're stood here at Matamata, we can't just jump straight to Tokoroa. What we need to do is actually have the one in between it activated first. So you cannot just jump from one node to the other like you can with Kruskal's algorithm, but first you have to actually activate a node and then move from it, and once another node is activated, then you can move on again. So I'm going to try and pick a colour that's going to stand out against against red, so I'm going to go for pink. So the first thing I'm going to do is check if I have to go from one place to another, if I have specific starting and end points. So it says we have to have the shortest route from Hamilton to Tapau. So the first thing I'm going to do is label those. So I'm going to activate this node by saying start, and I'm going to activate this node by saying end. And I think actually that pink isn't standing out enough, so I'm going to try the orange, we'll try the orange and see if that works, and if not, we'll change to purple. So we're going to start at Hamilton, and we're going to go down the smallest node from it. So to Matamata it's 68 kilometres, to Cambridge it's 23, to Tiawamutu is 29, and Purongia is 32. So I'm going to go down this way, and so I'm going to write a label to myself to say that I'm going from Hamilton to Cambridge, and that total that I've travelled so far is 23. And then what I'm going to put here is I'm going to put a running total. So my running total so far is 23. I'm just going to label that RT. So now I need to look at Cambridge or Hamilton and say which one is the shortest route from there. So Cambridge can travel either 41 to Matamata, 32 to Tirau, 24 to Tiawatamutu, or to Purongia. So from here, the shortest distance would be to Tiawatamutu. So straight away, I've just travelled 29 again. So I've travelled 29, and my running total would be 23 plus 29. So if you're worried about your maths, you can, 23 plus 29, and that's going to be 20, 40, 52. So far I have 52 metres or kilometres that I've travelled, and the place that I went from was Cambridge, and I travelled to okay. So now I'm going to look, and I'm heading towards here. I'm going to say, well, actually, I could travel 29, 24, 61, 70, 48 or 12. The problem with 12 is, if I travel down here, although it's my smallest, so technically I probably should pick it, it's not helpful because I'm actually not travelling in the right direction and I'd have to go back in a circle. So I can put a label here, just explaining to the examiner that I'm not going to follow it, because it creates a cycle. And what I mean by a cycle is, if I follow that route, eventually I'll just go back round on myself. So now I'm going to have a look at the other numbers and say, well, I'm definitely not going to do this one, so I'm going to cross it through. That's my pink pen. Okay. So I'm definitely not going to travel that way, so I've crossed it out. And I've explained why, so the examiner can see why. Then I'm going to look at this and say, well, actually my shortest route would be down here. So that's going to be Tiawamutu to Tikuiti. So that would be 48. And I have and so I would do 52 plus 48, which gives us a nice round 100. So the examiner can see that not only am I thinking about what I'm doing, I'm realising when the technique I'm using isn't effective and I'm adapting it, so it shows higher thinking skills, and also I'm keeping track, so the examiner can see that I'm thinking really systematically about what I'm doing. Okay, next job. So here I'm at Tikuiti and I can either travel 114 to Tokoroa from it, or I can travel straight to Tapau for 113. So that's what I'm going to do because it's the smallest. So I end up at Tapau, which is 113. So I'm going to now, wrong pen. I've got 113 and I travel from Tikuiti. Now I've been really systematic. An examiner or a lay person, meaning somebody that doesn't know anything about this, would be able to follow my logic and see what exactly I'd done. And I've coloured it to make it stand out, and I've explained any decisions that I've made. So now I need to do running totals. So I've got 113 plus 100, so that's going to be 213. So at the moment, my shortest route using this method, is 213 kilometres. So I'm pretty happy with that so far. So that's method 1, which is the shortest arc from a currently activated node.